Greetings to my university lecturer, Dr. Ashadi. I'll introduce myself first. I'm Kaushalya Nair Anaprampan Prabhakaran. My matrix number is B0819100046. I'm studying Bachelor's of Electronic Engineering Technology, major in Telecommunication. Currently doing my internship in Coherent Corporation under Mr. Yafik Xiong. Before starting my presentation, I'll explain about the content of my presentation. First of all, I'll be explaining about the company profile, following with ESC practice, RODAM department, industrial training scope, and finally ending with the conclusion. As we can see, Coherent employed 28,000 plus employees in 130 locations around 24 different countries. Here we can see some examples of the products made by Coherent, which are optical communications, optoelectronic devices, optics, and etc. As our company are producing electronic devices, we must follow the ESC practice, which is electrostatic discharge. So, when we are entering the production line, we must wear ESD smoke. This is to conceal their insulating clothing and to reduce the electric fields produced by the clothing. When we are entering the plant, we must wear ESD shoes. This is to safeguard the wearer against electrostatic discharge. And finally, the ESD strap. This is to ground individuals who interact with sensitive electronic components, and this is worn on the wrist and is connected to a standard wall receptacle via an earth bonding plug. Moving to the RODAM department, RODAM is also known as Reconfigurable Optical Airdrop Multiplexes. Under the RODAM unit, there are two different subdivisions, which are Amplifier Line Card ANL and Advanced Component Product Line ACPL. So under ANL, OA1T, OMS, RLS, JYJ, and WL5 products are made. Under ACPL, there are 1x18 and C32 products. On the right, it is an organization chart where I was placed under Mr. Yap Chi Seong, Engineer 2, as an intern. So now I'll be explaining about the OMS assembly. OMS stands for Optical Monitoring System. This module consists of 10 main components. So the final product will looks like on the right. For the sub-assembly process, sub-assembly A, it is an attachment of component J, component G, component F, component H, and component I. For sub-assembly B, it is an attachment of component C and component E. For the final assembly process, it is an attachment of component D, component A, component B, sub-assembly A, and sub-assembly B. This optic fiber routing process must be handled very carefully and fragile. This is because being knot can cause the fiber break to occur. So, the mechanical assembly consists of 7 types of screws and 4 types of torque drivers. For an example, for component F, we will be using the screw type C with the torque driver type of 3.0 kg F dot centimeter in a quantity of 4 pieces. Next, I'll be moving to the JYJ and WL5 testing. Here we can see two types of products, which are WL5 and JYJ. Both products are used to amplify signal like a booster. We can say that WL5 is a simplified version of JYJ. So both products are used to maximize OSNR value, such as local OSNR and global OSNR. OSNR stands for optical signal to noise ratio. So basically, I was assigned to perform clear fiber test every morning to ensure the tester is in good condition before the operators started to test their production modules. So here I learned to test the products using the software to increase the output. When the products pass the test, it will be moved to the next stage. While if the products fail, it will be sent to the rework. Next, pigtail bare fiber heating recipe evaluation. As we can see, the problem encountered here is the product is transferred from China to Malaysia The recipe used in the older version splicer doesn't produce same result in the newer versions of the splicer for pigtail bare fiber heating process. So you can see the process result from the old version. Here we conducted a DOE, design of experiment, for the pigtail bare fiber heating process based on the three main criteria on the new splicer. So we were able to produce 10 different recipes from the DOE test 1. DOE 9 and DOE 10 look similar to the expected result. Recipe to be further studied from both DOEs. Then, by conducting the DOE test 2, we were able to produce 6 optimized recipes. DOE 2 and DOE 3 look same and better than the expected result. Recipe to be further studied from both DOEs by the engineers. As we can see, engineer was happy with the result and would proceed to study the recipe and use on the product. Next, I'll be moving to splicer recipe evaluation. Here, the purpose of the task is to identify the splicing loss is within the requirement of the product specification. 24 different optical fiber combinations needed to be done. 10 data for each combination of fiber. A total of 240 data needed to be collected. So as we can see, this is the data collection setup, and the equipments used were IPA, industrial tissue, cleaver, hot stripper, power meter, and splicer. So as a conclusion, internship or industrial training is a very important part in the period of my studies. I was able to obtain various types of knowledge by conducting day-to-day tasks and project tasks. I was able to experience the real-life working environment with various types of obstacles that are needed to overcome to complete the task. The task helped me to organize and improve my time management to complete the task given within the timeline. I was able to learn and operate machines and systems which are high new technology that would not be available in the universities. I was able to train myself as a professional and to find my potential in this related field. So that's all for me. Thank you for giving me this opportunity.